Hey, what's up everybody? In this video tutorial, we're going to be taking a look at the Onshape levers assembly assignment. So what we're going to be doing with this is we're going to be taking a look at simple machines a little bit more. We're actually going to be incorporating Onshape into this, and we're actually going to be creating some simple machines. Okay, so that might sound a little bit terrifying at first. Here's what you have to know. We have provided the parts to you. We've been doing part creation basically since August. Now we need to start focusing on how things are put together and how to make things move in Onshape. And that is sort of, one of the big points behind this assembly. So, taking a look at simple machines, and we're going to go out there and build and create some really cool things using what we call joints. Okay, so the first thing you need to know is out on Google Classroom, we have this assignment. You're going to see that there's a link to our Google Drive folder right here. When we pick on this, you're going to see that there are many different parts that are available to you. These parts are what we call step files. So these were actually created with Onshape, but I exported them out as step files. What's interesting about step files, we can, you know, we can open up the parts, we can use them in assemblies, we can use them in drawings, we can use them in about everything. But the only thing we can't do is go back and sort of look at the timeline to see how it was made and actually change it or edit it. So they're sort of like dummy parts. They still work just fine. Just know that they cannot be edited. But for this, it's going to be absolutely perfect because we're just wanting the parts so we can do something with them. So what you're going to have to do first is go into Onshape. And what I would recommend that you do is create a new folder. And we are going to just simply be calling this our Onshape lever assembly assignment. Okay, so I'm going to go ahead and create that folder. So we have that folder created. Now all we have to do is just simply pick on it. And now what we're going to do is we're going to start importing those files from our Google Drive. Okay, so I'm going to come out and go to Create. I'm going to say Import Files. Okay, it might look a little different for me because I'm able to go right out there to my Google Drive. Okay, but you're going to be able to do the same sort of thing. So I'm going to be locating where those are at. And then I need to make sure I grab all those step files that we see within that folder and say open. Okay, when this comes up, all you simply have to do is hit OK. And now we're going to start seeing this upload in progress. Okay, and there's going to be a bunch of parts that are starting to come over. Okay, so it looks like I have all of my parts in here. So all I have to do is go ahead and close out on this. And now I can come up here and just say I want to create a document. And once again, I'm just going to call this my Onshape lever assembly. Okay, I can go ahead and create the public document. And now I'm ready to start getting going on this. Okay, so a couple of things real quick. All right, so we know what levers are, and we've heard about all sorts of different examples, but there's one thing I want you to remember basically for the rest of high school, rest of college. It's going to be helping you out. All right, it's just this little way to sort of memorize and understand what levers are. There's 3 different classifications of levers. Okay, so in order to remember this, the best way, okay, I've sort of learned is something called FRE or free 1, 2, 3. Okay, what this means is, that this is basically sort of a key explained to you how everything is sort of set up within the 3 different classifications of levers. Okay, so many of us think of levers, we think of the teeter-totter. That is a first-class lever. Okay, and if I came out here and drew this, we're going to see a board. Okay, here's the pivot point, which is what we call our fulcrum, so that's the F. Okay, we're going to have resistance down on this end. That's going to be one little kid. And then this is the kid that's, shoving down on this end. Okay, that's going to be the effort. All right, so this was, we said resistance. This we said was effort. Okay, or it could be flip-flop. This could be the effort over here, and this could be resistance. Okay, so that's what a lot of people think about with levers, but there's actually 3 different classifications. So a really easy way to remember this is with this FRE 1, 2, 3 sort of concept. In a first-class lever, the fulcrum is in the middle. Okay, in a second class lever, the resistance is going to be in the middle. Okay, in a third class lever, the effort is going to be in the middle. So if we were to draw a second class lever, we draw our board. Okay, we can see that our resistance is going to be here in the middle. So I can go ahead and mark that as an R. Then I could come to this end and I could put my fulcrum. Okay, and then on this end, I'm going to say that this is my effort. Just like so. Okay, and in a second class lever, a third class lever, okay, we have the effort in the middle. So once again, we can draw our board. Okay, we're going to go ahead and put our fulcrum at one end of this. Okay, and now we're going to go ahead and put our effort in the middle. So I'm going to go ahead and just say it is here. Okay, and then on this end, we're going to say that this is the resistance. Okay, so first class lever, like we said, that could be like a seesaw or a teeter-totter. Okay, the one we're seeing there on the left-hand side. On the right-hand side with the resistance in the middle, okay, we could look at that as like a wheelbarrow, okay, because we're pulling up the effort on the end, just like a wheelbarrow, and we have the wheel on the end that's going to be acting as our fulcrum. And then like, the effort in the middle, think about tweezers or barbecue tongs, okay, that would be a third class lever. So that's just a really simple way to remember the classification of levers. Okay, so with that being said, let's go ahead and just kill that. And let's go ahead and let's get started. Okay, so what we're going to be doing first is we're going to be constructing our first class lever. All right, so what I'm going to do is I'm going to come down here to my assembly at the bottom. Okay, and then what I'm going to do is I'm just going to come up here, go to Insert. I'm going to go and find Other Documents. I'm going to go into my Onshape, and I'm going to go into my Onshape lever assembly assignment. Okay, so with the first class lever, okay, I'm going to be looking for my first class lever arm. Okay, I'm also going to be looking for a fulcrum. I'm going to be looking for an effort. And then somewhere in here, we also have a resistance. So let's just start with something that I know is going to be permanent. Okay, we're going to fix this. It's going to be pinned down. It's not going to be able to move. So I'm going to go ahead and pick on fulcrum. I'm going to pick fulcrum here. I'm going to move this over, and I'm going to pick to drop that into our environment. Okay, once I have picked that, I'm going to go ahead and green check it. All right, so we can see that that is our fulcrum. Now, the problem is right now, if we grab this, we can see that the fulcrum actually moves. So I want to make sure that's in a static position, meaning that it's pinned down. So I'm going to right-click on top of my fulcrum, and I'm going to come out here and pick on Fix. Now when I go to pick and drag this, okay, it's going to give me a little symbol saying, nope, I'm not going to move. And that's exactly what we want it to do. We want to keep it right there. Okay, so now I'm going to come up and go to Insert, go into my Other Documents, go into my Onshape, find my lever assembly assignment, and now I'm going to come down and find my first class lever arm. I'm going to pick it, I'm going to pick it here, and I'm just going to go ahead and just pull that in. Okay, we know on a first class lever, okay, that fulcrum is going to be in the middle, and if you take a look at the top of the fulcrum, we can see there's sort of a cylinder there, and we can also see at the bottom of the board in the center, okay, there's that sort of groove that's been cut out. Okay, so that's why that makes it a first class lever arm. Okay, so now what we're going to do is come out here, go to Insert, go to Other Documents, go into Onshape, go into my lever assembly assignment, and now I'm going to come down here and find my effort. I'm going to pick on that, and I'm going to go ahead and just drop that in, okay, and green check. So now I have my effort. And one more time, I'm going to go to Insert, go into my Other Documents, go into Onshape, my lever assembly assignment, and now I'm going to come down and find my resistance, which is just basically a weight. So let's see if we got that in there. Okay, looks like I got too many. Okay, so we have all the parts that we need for our first class lever. So now we're going to go ahead and start applying our joints, our constraints to it to make it act the way that we want to. Okay, so up until this point, we've basically just been doing assemblies where things are basically stacked on top of each other. We've really just kind of done that, like with cookie cake. I mean, we were just stacking stuff on top of each other. We were using like planer mates and fasten. Same thing with turkey cookie. we haven't really done a whole lot to make these things, kind of lifelike. All right, so that is another big part of this assignment. So we're going to go ahead and start looking at all the different options we have as far as joints go. When we look up here across the top, okay, we're going to be seeing all sorts of different joints that are available. Okay, first one we've already kind of worked with is fasten mate. Okay, the second we have here is going to be revolute. The third one is going to be slider. The fourth one is going to be a planar mate. The fifth one is going to be a cylindrical mate. Okay, this one here is a pin slot. This one is a ball mate. We have parallel mate, and we have tangent. Okay, for a good majority of the levers here, we're only going to be dealing with a couple of them, but it's going to be giving you some more experience with it. Okay, so the first thing I want to do is I want to take that board and I want to put it on top of the fulcrum. But the thing is that board is going to be able to rotate. Okay, so what we're going to be using is something called a revolute joint. So here's how this works. It's really simple. Okay, we come up here and we find our revolute mate. We pick on revolute. I'm now going to be coming over here and zooming in, and when I get to the end, okay, of this sort of semi-hole here, what you're going to be seeing is this marker. This marker is what we call a joint origin. So what we're going to do is we're actually going to be picking two joint origins and then telling it how to behave with the type of constraint that we have picked. So right now we're currently in revolute. All right, so I'm going to go ahead and just find this joint origin and pick on it. I'm going to zoom out. And then I'm going to come over here to this front face right here and find this joint origin and pick on that. Looks like I missed it the first time. Okay, so when I do that, all right, we can see it brings those two together. All right, so we have this revolute box over here. Let's take a look at that. So we have some different options. The first option is it's going to allow us to do a flip. Okay, so let's just pick on flip. Let's just see what happens there. So when I orbit this over, we can see that has totally flipped that over and it's brought those two faces together. That is not correct for what we're wanting, so I'm going to go ahead and pick it again and send it back into that primary axis. The next one we have here is to reorient this on a secondary axis. So if I pick this, now we can start seeing how it's going to start spinning, okay, all the way around. It's going to give us like 4 different alternate positions. All right, so you have a couple options there to kind of get this in the right, orientation that you want. But for what we're wanting right now, we just want that board sitting on top of the fulcrum. Okay, so I'm going to go ahead and just green check it. Okay, and I can go ahead and just close out of this. All right, so right now, all right, you're going to see how this is going to start teeter-tottering back and forth. Okay, so I'm going to go ahead and just undo that, bring it flat. Okay, so now what I have to do is add my effort, okay, and add my resistance to this. So in order to do this, I'm going to be flipping this over. I'm going to come up here and I want to fasten this to one end of that board. So I'm going to go ahead and pick on fasten mate. I'm going to come right on in here. All right, and I'm going to see that this joint origin is right here directly in the center of this face. I'm going to go ahead and pick it. I'm going to zoom out, orbit this over, and I'm going to bring that right on top of this face. Okay, now we have to be careful because sometimes, okay, you're going to see how it's going to be changing the orientation of that joint origin depending on the face that you are working with. Okay, we want to make sure that that is flat on that face and in that particular location. I'm going to go ahead and just pick it. So now we can see that effort is right there at the end of the board. All right, but the thing is, I don't want it right at the end of the board. I want to bring it in just a little bit, like if a little kid was actually sitting on the teeter-totter. Okay, I want to go ahead and bring that in. So in order to fix this, over here underneath fasten, you're going to see this offset box. It's going to give us options for the X, Y, and the Z axis. If you don't know where those axes are, hover in close, and it's going to give you something called a triad. We can see that the positive Y is going in this direction, the positive X is going in this direction, and the positive Z is going down in this direction. I want to slide it, okay, over in this direction about 1.5 inches. So what I'm going to do is I'm going to come here. I can see that is my X-axis. I'm going to pick here my X-axis, and if I want it to go to the left, that's going to be in the negative because the line is indicating the positive on the Y. So I'm going to say this is going to go over negative 1.5. And if I come down here and just pick in the Y, we can actually see that slides over. And it's even going to tell you how far it went over in the X. And that's all we have to do for the effort. Now, if you're looking at this and you can't see like the effort name or something, just don't forget, you always have the ability to spin this. Okay, if you'd like to do that. Okay, you can always flip it here as well. But honestly, this is perfect for what we're wanting it. So I'm going to go ahead and just green check it. So my effort has now been put into the right location. Okay, the last thing we have to do is add our resistance. So just like we were doing with effort, I'm going to come down here and find fasten mate. I'm going to orbit this over, come to the bottom side of this, and I'm going to find the joint origin. It's the very bottom of the surface. I'm going to pick on that joint origin. I'm going to flip this over, and now I'm going to be here on top. I'm going to be finding the joint origin for the very end of that board. Okay, so just like last time, we can see that our resistance is hanging over the edge just like it was with effort. So we're going to go to offset. Okay, and now I'm going to go ahead and start looking at my axes. So if I kind of zoom in close here, my X positive is going to be coming in this direction, and that's the direction I want to go. So I'm going to say I want to go ahead and bring this and scoot this in about 1.5 inches. We can see that just brings it over on the board, and now I'm going to go ahead and green check it. All right, so we're basically set. All right, we have built our first class lever. We know it's a first class lever because our fulcrum is in the center. All right, and now what we need to do is to animate this. Now the thing is, when we animate this, all right, we saw it before how it was able to just sort of flip completely around. All right, obviously if it flips over too much or if it rotates too much, it's going to be slamming into this face right here. So what we're going to be doing is we're going to start setting up some limits within our revolute joint. So in order to do that, I'm going to right click here on revolute. I'm going to come down and do an edit. So one of the options that we see is limits. So I'm going to go ahead and pick on limits. And now it's basically going to be asking us, hey, how many degrees do you want to make your maximum? How many degrees do you want to make your minimum? So when I create this rectangle, all right, this triangle, basically it's going to be 60 degrees down. All right, so in order to do this, I'm going to say for my minimum, I want my minimum to be -60 degrees, and I want my maximum to be 60 degrees. Okay, so we're going to see how this is going to go -60 over to the right, and then it's going to be able to go to a +60 over to the left. And in order to make sure that this is right, we can hit the play button, and that is going to give us a preview on what we just set up there, okay, within our revolute joint and our limits. So if we see that that is correct, and we're seeing that both of those faces are going and slamming against those faces, they're not actually going into them, now we can go ahead and just green check it. Okay, and the last part of this is just to go out there and actually animate the entire model and watch how this all works as a first class lever. So in order to do that, I come here to revolute. Okay, I'm going to come down here and I'm going to pick on animate. And all I have to do is just hit the play button, and it's going to be slowing this down, and we're going to be able to see how this first class lever, okay, works just like so. All right, and that's it. All right, so the animation that you're looking at right now is the animation that you need to grab a screenshot of, all right, in order to turn in for the assignment. All right, so you're just going to let that play. You're going to get the screenshot of that, okay, as a video, all right, actually showing the animation, so we know that you actually did this correct. Once that is done, we can hit stop. We can go ahead and close out, all right, and that is really it, okay, for a first class lever. Okay, so now we're ready to get started with our second class lever. So second class lever, okay, if we look at the FRE123 model, we can see that resistance is what is going to be in the center, okay, of our lever. So I'm actually just going to stay right here within the same assembly. I'm going to build all three of these levers right here. So what I'm going to do first is I'm going to pick on insert. I'm going to go to other documents, go into Onshape, into my lever assembly assignment. I know I'm going to need a fulcrum, so I'm going to go ahead and just pick and pull that in. Okay, I also am going to need my effort, so I'm going to go ahead and pull that in. I'm also going to need a resistance, so I'm going to go ahead and pull that in. And the last thing I'm going to need is going to be my lever arm. All right, so you're also going to be finding in here that there is a second and third class lever arm. What is the difference between them? Well, the notch has now been moved, okay, to the different end of the board. So on a first class lever, we knew the notch was in the center. Now we can see that this is here on the end. Okay, so I'm just going to go ahead and spread these out just a little bit. I'm going to go ahead and get my fulcrum right-clicked. I'm going to go ahead and fix it. Okay, and now we're basically ready to get started. So my resistance is going to be in the center, all right? But before that, we need to go ahead and put the board on top of our fulcrum. So just like last time, we're going to be coming up here, finding revolute. I'm going to be zooming on in here to the top of this hole. Okay, find that joint origin. I'm going to pick on it, zoom out, and then come here to this tab on top, coming right here to the surface and picking on it there as well. All right, everything is looking good. If it is not, remember, you always have the ability to start doing flips and reorientation around that axis, but that's exactly the way that I want it. So I'm going to go ahead and green check it and close out. All right. So we said in the second class lever, our resistance is going to be in the center. So now we can come up here and go to fasten mate. I can flip this over, look at the bottom of my resistance, find the joint origin. It's in the center of that face and pick. I'm now going to go ahead and zoom on to the top of the board, find the joint origin that's right smack dab in the middle. Okay, go ahead and pick on it. All right, and now if we take a look at this, I don't know, maybe we want to scoot it to the left a little bit. I don't know. Let's just go to offset, go to my X. My X positive is going to the right because it's showing it with the line. So I'm going to go to the negative and just say, I don't know. Let's just go -1 maybe just to scoot it over just a little bit. I'm going to go ahead and just green check it. Okay, so the last thing we need to add is our effort. Okay, so let's go ahead and this time, let's go with fasten mate. I'm going to orbit this over, find the bottom of our effort, look for that joint origin that's flat right there on the center of that face. I'm going to go ahead and pick it. And now this time, instead of this being up here, I'm going to be flipping this down. I'm going to be bringing this in to find my joint origin, which is right here. Okay, make sure it's on the right surface. I'm going to go ahead and pick it, and that's going to place it. All right, so now we're looking at one of these instances where we can start doing some flips. Okay, so the effort, we want to come from the bottom. So I'm just going to come over here to my flip primary axis, make sure it's coming in from the bottom, which it is. And then actually at this point, we can go ahead and spin this where we can actually see the effort, okay, on this side of the object. Okay, so since that's right there on the end, I'm going to go ahead and just go to my offset. I'm going to look at this from the front view. We can see my positive X is now pointing to the left. So now I can just go ahead and just say, hey, move that over 1.5 inches. Okay, we can see how that sends it over. I can green check it. All right, and that is my second class lever. All right, so obviously we need to animate this. So for my second class lever, I'm going to be coming down and finding my second revolute. I'm going to right click on it. I'm going to say edit. My limits on this case are basically going to be the same exact limits that I did last time. So I'm going to say it's going to be a -60 degree for my minimum, and it's going to be a +60 for my maximum. And now what I'm going to do is just go ahead and hit the play button. And we can see it's basically making contact with the faces. It's not going within the actual object. Okay, so I'm going to go ahead and just green check it. All right, in order to make sure all this is working right, I'm now going to come back to my revolute. I'm going to right click. I'm going to say edit. Nope, I don't want to edit. I want to animate it. Okay, I'm going to go ahead and hit the play button. And now this is going to be a little bit slower. And now we can see how the effort is actually shoving this up. The resistance is in the center there. All right, and it is behaving just like a second class lever. And if you're trying to remember what a second class lever example is, this would be a wheelbarrow. So think about, the load that we have. It's gravel, it's dirt, whatever. It's in the center of the wheelbarrow. The wheel is acting as the fulcrum. And then we are using our legs and our arm strength to pull up on the wheelbarrow, all right, in order to lift it up and to move it with the wheel. Okay, so that would be a second class lever. Okay, so now we're ready for our third class lever. So let's go ahead and start getting that set up. So I'm going to go to Insert, go to my other documents, go into my lever assembly assignment. and find everything that I'm going to need. So we're first going to need our fulcrum once again. So I'm going to go ahead and just bring that in, drop that in. I'm also going to need my resistance and my effort. Drop those in. There's my resistance. And the last thing we're going to need is going to be our second and third class lever arm. So I'm going to go ahead and just drop that in. Okay, so we have all the parts that we need. So the first thing we need to do is come here to our fulcrum. We're going to right click and pick on fix. All right, so he's no longer going to be able to move. Just like last time with the second class lever, we're going to come up here and go to revolute. We're going to get in close on this hole, find this joint origin that's right here and pick on it, and then take that to that top sort of tab, that cylinder, find the exact center of that for that joint origin, and go ahead and green check it. All right, so for a third class lever, FRE 123, we can see that the effort is going to be in the center, okay, of the board. All right. So if you sort of think about a third class lever and the effort being the center, think about tweezers, think about, barbecue tongs. So we're actually going to be bringing this effort up from the bottom. All right. I think that's right. Yeah, it's right. Okay, so we're going to go ahead and, let's just go ahead and place that resistance here at this end right here, and then we'll start with the effort here in the center. Okay, so we have our revolute taken care of, so we can get out of that. Now we're going to come up here and go to fasten. And now let's just start with resistance. We'll keep it simple. Okay, we'll start with our resistance. We'll find that joint origin. We'll pick on it, orbit this over, and now we'll bring here to the top, find our joint origin here at the end. We'll go ahead and place that to get it where we want. Maybe we can even spin it where we can actually see resistance. Okay, and now looking at this from the front view, okay, it looks like now some things have changed with my axes. So if we look here, positive Y is going here to the left. So if I go into offset, now I can go into my Y. I'm going to say I want to just scoot that over about 1.5 inches in the positive Y direction. Okay, so it's not falling off the end of the board. Okay, so we have our resistance done. Okay, now we can go ahead and start working with our effort. So now I'm going to come up here, go to fasten mate. I'm going to orbit this over, look at the very point of this effort. Go ahead and pick on that joint origin. And now I'm going to come in here and just find the joint origin that's in the dead center of the board and pick it, okay, to place that just like so. All right, so we have some options to come out here and start doing some flips. So let's go ahead and do the flip. Let's get that in the right orientation, and then let's just go ahead and move this around with our secondary axis just so we can see that effort. And the last thing I want to do is just scoot this to the left, and we can see that as positive X because of the line. So I'm going to go to offset, go to my X, and add my 1.5 inches just to scoot over just a little bit, maybe just 1 inch. Okay, and now I can go ahead and green check it. Okay, so here we go. Now we need to go out here and change our Revolute 3. So I'm going to right click on it. I'm going to say I want to do an edit, and now I can start setting up my limits. So for my third class lever, just like the other two, our minimum is going to be -60 degrees. Our maximum is going to be 60 degrees. Once I have those plugged in, go ahead and just hit the play button, and we will see it is behaving just like it should. So let's go ahead and green check it. And then finally, let's come down here to Revolute 3. Let's animate that, hit the play button, and there we go. So the piece of meat that's on the barbecue tong, that's going to be the resistance. And it's our hands, our fingers that are clamping those two ends together. All right, that is what's providing the effort. So that's why I say barbecue tongs or tweezers. All right, and so once we see that that is done, we can go ahead and stop it and close. And just that quickly, we have just assembled 3 classifications of levers. And we've gone out there and we've used some joints and we've done some animation. Just don't forget for this assignment, you need to make sure to get 3 videos, all right, the screen capture videos showing those animations for all 3 in order to get the full credit on this. And there you go. That is our first experience with Onshape joints and some real assemblies that actually do something. Have fun with that and good luck.